Hello everyone, in this video we're going to review AP Precalculus topics 2.3, 2.10 and 2.11 exponential and logarithmic graphs. Before we're going to dive into the review, let's activate prior knowledge. We're going to explore the end behavior and concavity of the exponential functions. So exponential function is given by the formula y equal to a times b power of s, where a is the initial value or the y-intercept, b is the common ratio. Now, a must be different from 0, b must be different from 1. Alright, so we have two different cases. If b greater than 1, this is the exponential growth. If b greater than 0, less than 1, this is the exponential decay. Now we have four different cases. The first case, a greater than 0, b greater than 1. Alright, so this is exponential growth. So the function rise from left. So it's going to be something like this. Now, the second case, a greater than 0, b greater than 0, less than 1. So this is exponential decay. So the function falls from left. Now the third case, a less than 0, b greater than 1. The function looks like this. And the last case, a less than 0, b greater than 0, less than 1. So the function looks like this. So in four cases right here, the exponential function receives the x-axis as the asymptote. Alright, so this is the x-axis. The function of the x-axis is y equal to 0. Keep that in mind. The function of the y-axis, which is x equal to 0. We're going to use decimals to demonstrate the graph of four different cases of the exponential functions. The first case, a greater than 0, b greater than 1. So I'm going to let a equal to 1 and b equal to 2. Alright, so I have the first exponential function, y equal to 1 parenthesis 2 power of s. Alright, so it's going to be like this. Now the second case, I'm going to let a equal to 1, but b equal to 1/2. So let's see how it looks like. Y equal to 1 times 1/2 power of s. Right, it's going to be like this. So look, it looks exactly the same thing as this guys right here. Now, case number 3. A less than 0, b greater than 1. So I'm going to let a equal to -1, b equal to 2. So the third case, y equal to -1 times 2 power of s. Alright, it's going to be right here. So it looks like this one. And the last one, a less than 0. So I let a equal to -1, and b from 0 to 1, so let's b 1/2. Alright, so I'm gonna have the last one. So y equal to -1 times 1/2 power of s. So it could be like this. Alright, now we're gonna explore the end behavior and concavity as well as increasing or decreasing. Alright. Now, in order to explore the end behavior of the exponential function, the first thing we need to do is to put the positive infinitive on the right of the x-axis, negative infinitive on the left of the x-axis, positive right here, and this is negative right here. Alright, so limit of the function f of s. So this is the function f of s. When s approaches negative infinitive, so you see that when s approaches negative infinitive, which means s going further to the left, the function is the red line right here, getting closest to the x-axis, and as we know that the x-axis, which means y equal to 0. So the limit of the function f of s when s approaches negative infinitive is going to be equal to 0. Now b, limit of f of s when s approaches positive infinitive, so which means s going further to the right, right? And the function going up, so which is the function approaches positive infinitive right here. Alright, so it can be positive infinitive. Now next one, we need to explore to see if the function is increasing or decreasing at an increasing rate or decreasing rate. Alright, so before we do that, let's take a look at the trick. We call this is Christmas tree trick. Alright, now if you see the lines going up from left like this is increasing, which is the slope is positive. The guys going down from left like this, the slope is negative. If you see the horizontal line, the slope is 0. If you see the vertical lines, the slope is undefined. Alright, so I'm going to use this Christmas tree. Now look at this one right here. I'm going to draw a tangent line to see if the function increasing or decreasing. Alright, so I keep drawing tangent line like this. And you see that it looks like this line right here, right? Right. So the function is increasing, right? Now, the function is increasing at an increasing rate or decreasing rate. So we start from here. We know that the horizontal line right here, the slope is 0. So we start from 0 and then it's getting steeper and steeper. So, right, so if it goes this way and if it's getting steeper, the slope is bigger. Alright, so which is the function is increasing at an increasing rate. Alright, now in order to understand if the function is concave up or concave down, okay, so we look at the streak right here. So if you see a bow like this here, the function is concave up. Alright, now let's move on to the second case right here. Alright, we have the limit of the function f of s when s approaches negative infinitive. So when s approaches negative infinitive, the function approaches positive infinitive. Look, it keeps going up forever. So it could be positive right here. So we have limit of the function f of s when s approaches negative infinitive is positive infinitive. Now, next one, limit of the function f of s when s approaches positive infinity, right? So when s approaches positive infinity, which means s going further to the right, the function getting closer to the horizontal asymptote, which is 0 right here, right? So this guy must be equal to 0. Now see, the function is increasing or decreasing at an increasing rate or decreasing rate. We just draw tangent lines, right? So we see that the tangent lines go this way, right? Which is this one right here. So the function is decreasing. Now, if we keep drawing tangent line, we see that if the tangent lines go this way, right, the steeper, the smaller slope. Alright, so this is steeper right here, and this guy getting less steep, and this guy getting less steep. Alright, so the tangent line getting less steep, and until the tangent line approaches 0, which is the horizontal line right here. Alright, so which means the function decreasing at an increasing rate, right? Because, for example, this guy equal to -5, right? This is -4, right? -3, -2, etc. until 0, right? So you see that the slope of the tangent line is increasing, right? So this is decreasing at an increasing rate. Now we need to determine if the function is concave up or concave down, right? So this is part of this guy right here, right? So the function is concave up. So the function is concave up. Alright, let's move on to number 3. Alright, so we have the limit of the function f of s when s approaches negative infinity. So when s approaches negative infinity, which means s going further to the left, the function getting closer and closer to 0, right? So this guy must be equal to 0. Now, limit of the function f of s when s approaches positive infinity, right? When s approaches positive infinity, the function getting down to negative infinity, right? Negative infinity right here, because it keeps going down right here, right? So it's going to be negative infinity. Now, see, the function decreasing, right? Because we draw a tangent line, we see that the tangent lines go in this way, right? Which is this one right here, right? The tangent lines go in this way, so this is decreasing. Now, decreasing at an increasing rate or decreasing rate. So we keep drawing tangent line. We see that the function starts at 0 right here. It keeps getting steeper and steeper, but steeper this way right here. So which means the slope getting more negative, right? So if it's getting more negative, which means the function decreasing at a decreasing rate. Alright. The function is concave down. If you see something like this, alright, part of this guy, right, the function is concave down, right? So the function is concave down. Now let's move on to the last one. We need to find the end behavior of this exponential function. So limit of the function f of s when s approaches negative infinity. So when s approaches negative infinity, which means s going further to the left right here, the function getting down, right? So it's going to negative infinity right here. So it's going to be negative infinity. Now b, the limit of the function f of s when s approaches positive infinity. when s approaches positive infinity, which means s going further to the right, right? And the function getting closer to 0, right? So which is 0 right here. Now see, the function is increasing or decreasing at an increasing rate or decreasing rate. So we need to explore that one, right? So we start right here, we see that. Now we start drawing the tangent line right here, right? The tangent line right here. You see that the tangent line is getting less steep, right? And you see that the tangent line is going this way right here, right? Which means it's positive, right? It's positive, which means the function increasing. But it's getting less steep, right? Until it approaches 0, right? So the function is increasing at a decreasing rate, right? We're gonna learn about the logarithmic functions. Suppose I have the function y equals 2 to the s. Alright, so this is exponential function. Alright, we have the general form. The exponential function is going to be y equals a times b to the s, right? So in this situation, a equals 1, b equals 2, right? 2. We have two different cases of exponential function. The first case, b greater than 1. The second case, b greater than 0 and less than 1. So in this situation, b equals 2, which is greater than 1. So we're going to explore the first case, b greater than 1, right? How do we find the logarithmic function? We know that exponential function is the inverse of logarithmic function, and logarithmic function is the inverse of exponential function, right? So if both functions are inverse, they will reflect each other over the line y equals s, right? So I'm going to draw like y equals s. It's going to be something like this. Now the logarithmic function will be the reflection of the exponential function over the line y equals s. Alright, so you look at this one, the y-intercept right here, 0, 1, becomes the s-intercept right here, 1, 0, right? You're going to pick another point. This is 1, 2, and this becomes 2, 1 right here, right? This one, 2, 4, right? And this becomes 4, 2. So this 4 and 2 right here. Alright. And then you just connect this point. Now, in order to find the equation of this logarithmic function, we just take the inverse of this one. Alright, so how do we do that? Right, so we just swap x and y. It's gonna be s equals 2 to the y, right? And then we look at this one right here. We see the base 2. So we're gonna take log base 2 both sides, right? So this guy's same thing as log base 2 of s log base 2 right here, right? So I just fill in the blank right here. This is s and this is 2 to the y. All right. Now this one I just bring y to the front, right? So it's gonna be log base 2 of s equals y times log base 2 of 2. But log base 2 of 2 is equal 1, right? So I have y equals log base 2 of s, and y, which means f inverse of s equals log base 2 of s. So the logarithmic function has the equation log base 2 of s, and this guy y equals 2 to the s, right? Okay, so now we're gonna explore the end behavior and characteristic of these two functions, right? Now first, all right, now we need to find the s-intercept. So s-intercept is gonna be none, right? Because the exponential function right here never touched the x-axis, right? The s-intercept for the logarithmic function right here is gonna be 1, 0, right? 1, 0. Now the y-intercept for this one is gonna be 0, 1. and the y-intercept right here, none, right? Right, asymptote of this one should be the x-axis y equal to 0. The asymptote for this logarithmic function should be y-axis, right? S equal to 0, right? The function right here is you just sketch the tangent line and you use the Christmas tree trick. So I have the Christmas tree right here. Now if the lines go in this way, the slope is positive. If the slope is positive, the function is increasing. The lines go in this way, the slope is negative. And the function is decreasing. Alright. If you see the horizontal line, the slope is 0. If you see the vertical lines, the slope is undefined. Right? Now, when you draw a tangent line of this exponential function, it's going this way, which means right here, the slope is positive. Right? So because the slope is positive, the function is increasing. Now, you draw another tangent line. I draw this one right here. Alright, so look at the left hand side right here. If the line goes this way, and when the line is steeper, the slope is bigger. Now look at the right hand side. If the line goes this way, if the line is steeper, the slope is smaller. Now back to this question right here. So you see that this line and this line right here, right? From bottom to top, the line getting steeper, right? So because the line is steeper, the slope is bigger, right? Which means the rate of change is increasing. For example, the slope of this one equals 3, and the slope of this one is equal 5, right? So you see that to get 5 from 3, it's going to be increasing by 2, right? So the function is increasing at an increasing rate. Alright, now go to the right hand side right here. It's going to be the logarithmic function right here. So you're going to draw a tangent line. So I draw a tangent line. And I still see that the lines go in this way right here. And then the slope is positive. So because the slope is positive, the function is increasing. Alright, in order to know if the function is increasing at an increasing rate or decreasing rate, I need to draw another tangent line. So I draw another tangent line right here. Alright, so I'm going to compare the slope of this guy and the slope of this guy. So I use this one right here, right? The line is steeper, the slope is bigger, right? The slope of this line right here is bigger than the slope of this guy right here, right? So for example, this is 5 and this is 3, right? So you see that to get 3 from 5, does that mean it's going to be decreasing, right? So the function is increasing at a decreasing rate because the slope of the tangent line getting smaller and smaller, right? Now concave. Now if you see the bow like this, if I cut this one in half and I only see half of this one, half of this one. So if you see 3 cases right here, and then the function is concave up, right? So you look at this one right here, the exponential function right here is similar to this one right here. So the function is concave up. Now if you see the bow upside down like this, or you cut this one in half and you only see half like this or half like this, alright? The function is concave down, and you look at this one, it's going to be on the left hand side right here. So the function is concave down. Alright, the domain of this exponential function is going to be from left to right, and you see that the function keeps going up and right, right? Up and right. So the domain should be negative infinity to positive infinity, or you just say all real numbers, right? The domain of this one, you see that the asymptote of the logarithmic function is x equal to 0 on the y-axis, right? So the function starts from 0 all the way to the right? And the graph never crosses the y-axis. So the domain should be 0 to infinity. And you don't take 0 because x equal to 0 is the vertical asymptote, right? Now the range, which means you look at the y-axis, right? And you see that the function is always above this x-axis, right? And never touches the x-axis. So the range should be from 0 all the way to infinity, right? So you have infinity right here, negative infinity right here, positive infinity right here, and negative infinity right here. All right, so the range should be 0 to positive infinity. Now the range of this one is going to be negative infinity to positive infinity because the graph keeps going up, right, and going down, right? So the range should be negative infinity, positive infinity, right? And you know that because the exponential function and logarithmic function, they are inverse, so the domain of this function will be the range of the other function, right? You just grab it. The limit of the exponential function f of x when x approaches negative infinity, right? This is called left limit. All right. So when x approaches negative infinity right here, the function approaches 0. It never touches the x-axis, right? So this guy should be 0 when x approaches negative infinity. Now when x approaches positive infinity, right? X go to the right and the function keeps going up forever, right? So this guy, this should be right limit. Alright, so the function of f of x when x approaches positive infinity is positive infinity. Now take a look at the logarithmic function right here. So we need to find the left limit and the right limit. So left limit right here and right limit right here. Now left limit, the limit of the function f of x when x approaches 0 plus. So keep that in mind. 0 plus, which means 0 from the right. So when x approaches 0 plus, the function approaches negative infinity, right? 0 plus, so it could be somewhere right here. So you see that the function approaches negative infinity because it keeps going down. So this guy negative infinity. Now the right limit. Limit of the function f of x when x approaches positive infinity. The function approaches positive infinity because it keeps going up, right? So this guy positive infinity. Now let's move on to the second case of exponential function. Now in this situation, I'm going to let y equals 1/2 to the s. So in this situation, b greater than 0, less than 1. And this is a decay function, right? Now I need to get the inverse of this exponential function. So it should be logarithmic function. So I need to get the line y equals x, and both exponential functions and logarithmic functions reflect over the line y equals x. Alright, so this is the logarithmic function. Now, in order to find the logarithmic function, I'm gonna rewrite the exponential function y equals 1/2 to the s, right? So I just grab x and y. So it turns out to be s equals 1/2 to the y, right? I look at the base right here, it's gonna be 1/2. So I take log base 1/2 both sides, right? So I have log base 1/2, and this is log base 1/2, right? So I put s right here. I copy everything down. All right, so this one I just print y to the front. So it's gonna be log base 1/2 of s equals y log base 1/2 of 1/2. Alright, so I know that this guy equals 1, right? So finally we have y equals log base 1/2 of s, and let's just change this one into inverse of s equals log base 1/2 of s, right? So the function right here, log base 1/2 of s, right? All right. Now the exponential function, the x-intercept is none, right? The x-intercept for the logarithmic function is going to be 1, 0. The y-intercept for the exponential function is going to be 0, 1. And then this guy's none. The asymptote, this guy exponential function has the x-axis. So x-axis as an asymptote are y equal to 0. Alright, the logarithmic function, the asymptote is the y-axis are x equal to 0. Now, look at this one and use the Christmas tree trick, right? I'm going to draw tangent line. So I draw a tangent line like this. And I see that the lines go in this way, so the slope is negative. The slope is negative, the function is decreasing, right? So decreasing. Now, I draw another tangent line to see if the function is decreasing at an increasing rate or decreasing rate, right? So I draw the next tangent line right here. Now I compare the slope of this guy and this guy. I see that the line less steep, right? The line less steep, the slope bigger. You look at this one, this guy and this guy right here. This guy right here is steeper than this guy. So the slope of this guy is smaller, right? For example, this guy's slope is -5, right? Because it's going this way. The line is steeper, the slope is smaller. And this guy is -3, right? So from -5 to -3, it's going to be increasing, right? So the function is decreasing at an increasing rate. Alright? Now, look at this guy right here. So I draw the tangent line right here, and I see that the lines go in this way, which means the slope is negative. The slope is negative, the function is decreasing, right? Now next one, I draw the second tangent lines of this graph right here, and I compare the slope of two tangent lines right here. I see that the tangent lines right here is steeper than this one. So if the tangent line is steeper, the slope is smaller, right? So this guy right here, for example, this guy right here, -6, and this guy is -2. You see that? And then, all right, so you see that from -6 to -2, this is going to be increasing. So the function is decreasing at an increasing rate. All right, look at the exponential function right here. We see that the function is concave up because it has this guy, right? So this is concave up. And the logarithmic function is also concave up. Now the domain, right? This guy keeps going further to the left. This guy keeps going further to the right. So the domain right here should be negative infinitive to positive infinitive. The domain for this guy is right, is from 0, right? Because the function never crossed the y-axis. So it could be from 0 to positive infinitive, right? Now the range right here, look at the exponential function right here, it's above the x-axis, so the range should be from 0 to infinity. And the range for the logarithmic function right here is going to be negative infinity to positive infinity, right? Nope, it keeps going down and this guy keeps going up. Now, the left limit and the right limit. So, left limit, look at the exponential function right here. Limit of f of s when s approaches negative infinity is positive infinity because the function is going up forever, right? This guy positive, this guy negative infinity, this guy negative infinity, and this guy positive infinity. Now, the limit of the function f of s when s approaches positive infinity, right? And then the function approaches 0, right? So it's 0 right here. Now, the left limit and the right limit of the logarithmic function. So the left limit of the function f of s when s approaches 0 plus the function approaches positive infinity, right? 0 plus right here, the function is going up forever. Now, the right limit, the limit of the function f of s when s approaches positive infinity, the function approaches negative infinity because it keeps going down forever, right? When s approaches positive infinity, right? Alright, so next we're going to learn how to sketch a logarithmic function. How do we know the function is going up, down, left, right, right? So we know that if I just write ln, which means the log base e, right? But if I just write log like this, which means log base 10, right? Now let's talk about log s, right? So log s, which means log base 10 of s, right? Alright, so let's explore 4 different cases of the graph of the logarithmic function. So the first one, this is the base case. I have log base 10 of s, so I just write log s right here. So the base case is going to be like this. Now let's recall the transformation of the function, right? It's going to be a times f of b of s minus h plus k, right? If you multiply the input by -1, the function reflects over the y-axis, right? So this guy right here, it turns out to be like this. Right? Now, the third case, if you multiply the output by a -1, alright, so the function reflects over the x-axis, alright? So original function right here, when it's reflect over the x-axis, it could be something like this. Alright, and the last case, if you multiply the input and output by a negative number, like this, and then the function reflect over the x-axis and the y-axis. Alright, so based on the transformation rule, right, we need to do B, H, A, K, right? So we need to do the horizontal dilation first, right? So we need to reflect the original function right here over the y-axis first, right? Because you multiply the input by -1. So I reflect over the y-axis. So it's gonna be something like this. Alright, so from this one, I reflect over the x-axis because I have the negative side right here. Now we need to do B first and then we do A later, right? A, which means vertical dilation, right? So -1 right here, and then I reflect over the x-axis. So it could be something like this. Alright, so the final answer should be this guy, the rest one. Alright, now the trick for you to memorize is you look at the side right here. Now you see that you don't see the negative side, which means this is positive and this is positive. Positive in front of the whole thing, which means y value. Positive in front of s, which means positive s, right? Positive s. So go to the right here. This is positive s. Go to the left is negative s. Go up positive y. Go down is negative y, right? So this go to the right. So s positive. Go up. This is positive y, right? Right here, right? Now this one right here, you see that positive y and negative s. So go over here, negative s, and go up positive y, right? Now look at this one, negative y and positive s, right? So this is positive s and negative y, right? Because the graph keeps going down. Now this one, negative y and negative s, right? So go to the left, negative s, and go down, negative y. So the function go to the left and go down, right? Now let's move on to the next example. So given the function f of s equals log base 5 of s, now describe the transformation of the function f of s to get the function g of s equals 3 log base 5 of s plus 2 minus 4, right? So we look at the transformation formula right here. Now we need to do the dilation first. So dilation right here, we have no horizontal dilation, right? Now we look at this one, this is the plus side, the formula is subtraction side, right? So whenever we see the plus side right here, think opposite. So first, right, the function f of s is moved to the left 2 units, right? Now next one, we talk about the vertical dilation, which means a right here. So it's going to be vertical dilation by a factor of 3. And the last one, we talk about negative 4 right here, which means k right here. Vertical translation down 4 units. Alright, so how do we find the vertical asymptote of this one? You just let this guy equal to 0, right? So you have s plus 2 equal to 0. You solve for s, so s equal to negative 2. So your vertical asymptote is s equals negative 2. Now to wrap this one, you know that original function log base 5 of s, it could be something like this, right? And then the new function right here is going to be vertical dilation, translation left 2 units, right? So you have the vertical asymptote right here 0, right? So you move to the left 2 units. So you have new vertical asymptote, it's going to be right here. Alright. And then the function is moving down 4 units and vertical dilation by a factor of 3, right? So it's going to be something like this. Alright, so you need to find a new domain. So domain is going to be from negative 2 to infinity, right? And the range is going to be all real numbers, right? So it's going to be negative infinity to positive infinity. Alright, the function is concave down. Now, the left limit of the function f of s when s approaches negative 2 plus, right? Negative 2 from the right, right? So negative 2 plus is going to be negative infinity, right? Because the graph keeps going down. Now limit of the function f of s when s approaches positive infinity. The function approaches positive infinity, right? because it keeps going up forever. Or you can use the trick I showed you in the previous example, right? You look at this one, this is plus sign, and this guy is plus sign, right? When s approaches positive infinitive, the function approaches positive infinitive, right? To the right and up. Alright, so to do this one, we just rewrite this one a little bit. So it's going to be 3 log base 5. Alright, so we just rewrite this one in this form right here. So I just factor negative 1 out. So I have negative of s minus 3 plus 1, right? The first thing I need to do is to find the vertical asymptote. So vertical asymptote is going to be, I just let this one equal to 0 right here. So I have 3 minus s equal to 0. So I have s equals to 3. Alright, so the first thing I need to do is look at the trick right here. I need to do horizontal dilation. So we have no horizontal dilation, alright, because the coefficient is negative 1 right here. But we have the vertical reflection, right? So the function f of s reflects over the vertical asymptote, right? It's not y-axis anymore, right? This should be vertical asymptote. Now next one, we talk about the h right here, which means horizontal translation. So obviously the function moves to the right 3 units, right? Now next one, we talk about the vertical dilation right here. So vertical dilation by a factor of 3. And the last one, we talk about k right here. K is equals 1, right? So this is vertical shift by 1. Alright, so now we're gonna graph this one. So we have the original function is going to be like this. The vertical asymptote is going to be 3. So this is 1, 2, and 3. 3 right here. Alright, so we draw a vertical asymptote. Alright, now we just get the new one. So the new one should be something like this. Alright, now we need to find domain and range of this one. Domain is going to be negative infinity to 3 right here, right? Range, it should be negative infinity to positive infinity, right? Because the graph keeps going down and going up right here. Now, the function is concave down, right? And we have a vertical asymptote as equal 3. Okay, now the end behavior. So the left limit of the function g of s when s approaches negative infinity, right? The function approaches positive infinity. Now limit of the function g of s when s approaches 3 minus, right here. This is the right limit. So it's going to be negative infinity because the function keeps going down, right? Now let's move on to the last example. So for example, I have the function g of s is negative log base 5 of s minus 3 minus 2, right? So the first thing I need to do is to find the vertical asymptote. So vertical asymptote, I let this one equal to 0. So s minus 3 equal to 0 and s equal to 3, right? So if I graph it, original function is going to be something like this, right? And then this guy's 1, 2, and 3 right here. So vertical asymptote is going to be right here, s equal to 3. Alright, so now I look at this one. I need to do horizontal dilation first, b. So there is no horizontal dilation. I skip this one. Next one, horizontal translation, right? So actually the function Actually, the function f(s) shifts 3 units to the right? Now, next one, we're going to talk about the vertical dilation, right? So there's no vertical dilation, but there is reflection right here, -1, right? So it's going to be -1 in front of the output, which means reflect over the s-axis, right? And the last one, this one, k equals -2. So this is the function f(s) shifts down 2 units, right? Alright, so if you grab it, it's going to be something like this. Alright, so for 3 different cases right here, you can use that most to check your answer. Now, let's move on to question number 1. The graph of the function f is shown above. Which of the following statements about f is correct? Alright, we know that the function f is decreasing, right? Because the rate of change is negative, right? If you draw the tangent line, it's going to be negative. Remember the Christmas tree trick, right? Right here, the slope is negative. Right here, the slope is positive, right? And the function is concave up, so the rate of change is increasing, right? Now, the function is decreasing, the rate of change is increasing. The answer must be C, right? Now let's move on to question number 2. The graph of the function g is shown above. Which of the following statements about the function g is correct? Alright, the function is concave up, which means the rate of change is increasing, right? Now we need to cross out b and d because it says the function is concave down, right? Now draw the tangent line, and you see that the slope is positive, which means the function is increasing, right? So the answer must be A. Now question 3. The logarithmic function h is defined by h of s equals -2 natural log of s, right? Which of the following statements about the function h is correct, right? Now we need to graph this one, right? So we have the parent function of the logarithmic function is going to be like this. Alright, now you multiply by -2 in front of the output, which means there is a dilation and reflection over the x-axis, right? So the final function should be something like this. Now this function is concave up, right, and decreasing, right? So the answer must be C. Now let's move on to question 4. The graph of the function k is shown above. Which of the following statements about the function k is correct? A. The rate of change of the function k is positive and increasing. Alright, so in order to know if it's positive or negative, we just draw the tangent line. And we see that the rate of change is negative, right? You just use the Christmas tree trick. This is negative, this is positive slope, right? So you're gonna cross out A and B, right? Now the rate of change is increasing or decreasing. We look at this one, we see that the function is concave up, which means the rate of change is increasing, right? So the answer is C. Now let's move on to question 5. The graph of f is shown above. Which of the following could be the equation of f, right? We know that this is the graph of the logarithmic function, right? So we need to eliminate C and D, right? Now, this is the parent function of the logarithmic function, which means there is no reflection at all, right? So the answer must be A. If the answer is B, it should be something like this. Reflect over the x-axis because we have the negative side right here, right? Now question 6. The logarithmic function L is defined by L of s equals -3 log base 4 of s. Which of the following pairs of statements correctly describe the end behavior of L, right? So we just get this one first, right? So we have the logarithmic function is going to be like this. Alright, now since you have the negative side right here, so there is a reflection over the x-axis, so it's going to be like this. Alright, so I need to erase this one. Alright, now I need to label positive infinitive right here. This is negative infinitive. This one is positive infinitive, and this one is negative infinitive, right? Now we're going to check the answer choice. Limit of the function ls when s approaches 0 plus, right? 0 plus, which means on the right hand side of the y-axis, right? So it could be right here. Right, the function approaches positive infinitive. This one say negative infinitive, so this wrong, right? Positive infinitive right here. So this wrong. Now the answer choice B, limit of the function L of s when s approaches 0 plus, it could be positive infinitive, so this one right? Limit of the function L of s when s approaches positive infinitive. The function approaches negative infinitive. Yes, that's correct, right? So the answer B is correct. Now let's move on to question number 7. Let the function h of s equals 2 times natural log of s minus 3 minus 5. Which of the following gives the domain of the function h? Find the domain of the logarithmic function. Recall that log base a of b is defined when a greater than 0, a not equal to 1, and b greater than 0, right? Now, since a is e, right, natural log is the same thing as log base e, right? So we don't need to worry about this guy anymore, right? We only worry about this guy right here. B greater than 0, which is the one inside parentheses. So s minus 3 must be greater than 0 at triple sides of s greater than 3, right? So which means it's going to be from 3 to positive infinity, right? So the answer must be C. Now let's move on to question number 8. The graph of f is shown above. Which of the following statements about the function f is correct, right? Now the function f is increasing. No, the function f is decreasing, right? Because if you draw the tangent line, you see that the slope of the tangent line is negative, right? So the function is decreasing, right? So you need to cross out a and b, right? Now we need to check for the rate of change. Now, because the function is concave down, which means the rate of change is decreasing, right? So the answer must be D. Now let's move on to question number 9. The logarithmic function k is defined by p of s equals 1/2 log s. Which of the following statements about the function p is correct, right? Now, we need to graph this one first, right? So, the function p of s can be graphed as follows. Now look at the answer choice A. The function p is increasing. Yes, because if you draw the tangent line and you see that the slope of the tangent line is positive, right? So the function is increasing. You need to eliminate C and D, right? The graph of the function p is concave up. No, this is concave down, right? So the answer must be B. Now let's move on to question 10. The value of the function k as shown in the table above. Add selected values of s. Determine if the function k could be linear, exponential, or logarithmic. Explain your reasoning. Now, in order to do this question, we need to determine the change in s and the change in y, right? Now, in order to get 6 from 2, we need to multiply by 3, right? This guy multiply by 3. This guy multiply by 3. The change in y is you need to add negative 2, right? This one add negative 2. And observe that the input values over the equivalent output values intervals are proportional, right? because every single time you multiply by 3. So this is a logarithmic function, right? So this is right here. Now let's move on to question 11. The function f is defined by f of s equals 3 times natural log of s. Which of the following could be the graph of f, right? So we know that the parent function of the logarithmic function is going to be like this, right? So because you have the positive 3 right here, so which means there is no reflection, right? So the answer must be A. Now let's move on to question 12. The logarithmic function f is defined by f of s equals 2 times natural log of s. Which of the following pairs of statements correctly describe the end behavior of the function f, right? So first we need to get this one, right? So the logarithmic function is going to be something like this. Look at the coefficient in front of natural log. There is no negative side, so there is no reflection, right? So we need to label this one positive infinitive. Now the answer choice A. Limit of the function f of s when s approaches 0 plus, which means on the right of the y-axis, right? So it could be right here, right? The function approaches negative infinitive. Yes, that's correct. It's going to be right here. Limit of the function f of s when s approaches positive infinitive. The function going up, right? Positive infinitive right here. So answer choice A, correct. Now let's move on to question 13. The function g is defined by g of s equals 3 times 2 to the s. Which of the following pairs of statements correctly describe the end behavior of g? Alright, so we need to get this one first, right? So we know that the exponential function is going to be y equals a times b to the s, right? If b greater than 1, it's going to be exponential growth, right? So in this situation, b equals 2, right? It's going to be exponential growth. So it could be something like this, right? Look at the answer choice A. Limit of the function g of s when s approaches 0 plus, right? So this one is talking about the vertical asymptote, right? So vertical asymptote only apply for the logarithmic function, right? So this is exponential function. So you need to eliminate answer choice A and B, right? Now answer choice C. Limit of the function g of s when s approaches negative infinitive. The function approaches the x-axis, right? Look at this one right here. So which means 0, right? So this one could be right? Limit of the function g of s when s approaches positive infinitive. The function approaches positive infinitive, right? So answer choice C is correct, right? Now question number 14. The function h is defined by h of s equals 5 times 2 over 3 of s. Which of the following pairs of statements correctly describe the end behavior of the function h? And you know that the exponential function y equals a times b to the s, right? A is positive and b greater than 0 less than 1, right? So this is an exponential decay function, right? So go ahead, get this one, right? So it could be something like this. Now let's take a look at the answer choice A and B right here. Limit of the function h of s when s approaches 0 plus, which is the vertical asymptote, right? So this one only applies for the logarithmic function, right? So we need to eliminate A and B, right? Now, answer choice C. Limit of the function h of s when s approaches negative infinitive. The function approaches positive infinitive, right? This say 0, so this is wrong, right? Answer choice D. The limit of the function f of s when s approaches negative infinitive, the function approaches positive infinitive. So this is right? Limit of the function f of s when s approaches positive infinitive, the function approaches 0, right? Because it's getting closer to the x-axis, right? So the answer choice must be D. Now, question number 15. The function f is defined by f of s equals negative 1/3 log s, right? Which of the following pairs of statements correctly describe the end behavior of the function f, right? So we need to get this one, right? So we know that the logarithmic function is going to be something like this, right? Now, since you have the negative coefficient right here, which means there is a reflection over the x-axis, so it could be something like this. Right? Now I need to eliminate the previous one. Right? Now answer choice A. Limit of the function f of x when x approaches 0 plus, which means on the right of the y-axis, the function approaches positive infinitive, right? Now it's a negative infinitive, so it's wrong, right? Now answer choice B. Limit of the function f of x when x approaches 0 plus, it could be positive infinitive. Yes, that's correct, right? Now limit of the function f of x when x approaches positive infinitive equals negative infinitive. Yes, that's correct, right? So the answer choice must be B. Now let's move on to question number 16. The function k is defined by k of x equals negative 1/2 times 3 to the s, right? So we need to get this one. Now we know that the exponential function y equals a times b raised to the s, right? B is 3 greater than 1, so this is exponential growth, right? So it should be something like this. Right? Now, since a is negative, right? A equals negative 1/2, right? So there is a reflection over the x-axis, so the final one must be something like this, right? Now, limit of the function k of x when x approaches negative infinitive. The function approaches 0, yes, because it's getting closer to the x-axis, right? Limit of the function k of x when x approaches positive infinitive, right? This is positive infinitive. The function approaches negative infinitive, yes, it's going down, right? So the answer choice A is correct. Now let's move on to question number 17. The function h is defined by h of s is negative 4 times 1/3 raised to the s, right? Now we need to get this one, right? We know that b right here equals 1/3, so b greater than 0, less than 1. So this is a decay function, so it could be something like this, right? Now, since you have the negative 4 in front of the output, so there is a reflection over the x-axis, right? So it could be something like this. Alright, now look at the answer choice A. Limit of the function h of s when s approaches negative infinitive. The function approaches negative infinitive, so it's a 0 right here, which means this is wrong, right? Answer choice B. Limit of the function h of s when s approaches negative infinitive. The function approaches negative infinitive, right? It's a 0 right here, so it's wrong. Answer choice C. Limit of the function h of s when s approaches negative infinitive equals negative infinitive. Yes, that's correct, right? Limit of the function h of s when s approaches positive infinitive. The function approaches 0, right? It's go to the right. The function getting closer to the x-axis, which means 0, right? So the answer choice must be C. Now let's move on to number 18. The function f is defined by f of s is negative 2 times 3 to the s, right? Now we need to sketch this one. We know that the exponential function y equals 3 to the s. It could be exponential growth function, right? So it could be something like this, right? Now, since you have the negative 2 in front of the output, so there is a reflection over the x-axis, so it could be something like this, right? Now, answer choice A. The function f is increasing. Alright, in order to know if it's increasing or decreasing, we need to draw the tangent line, right? So, the tangent line is going down, which means the slope is negative, right? So the function is decreasing, so you need to eliminate A and B. Now, answer choice C, the function f is decreasing, right? And the graph of f is concave down, right? This is concave up, so this is wrong. The answer choice must be D. Now, number 19, the function g is defined by g of s equals 6 log s, right? So we need to get this one, right? We know that the log function is going to be something like this, right? Now, answer choice A. The function g is increasing, right? We just draw the tangent line, and you see that the tangent line has the positive slope. So the function is increasing, right? So we need to eliminate C and D. Now the graph of cheese is concave down, right? This is concave up, so it's wrong, right? The answer choice must be B. Now question 20. The function h is divided by h of s equals 7 times 1/2 raised to the s, right? So we need to get this one first, right? So because b right here is less than 1 but greater than 0, right? So this is exponential decay function. So it could be something like this, right? Now the answer choice A. The function h is increasing. No, this is decreasing, right? Because you draw the tangent line, we see that the slope of the tangent line is negative, right? So you need to eliminate A and B, right? The graph of the function h is concave up, right? So this is concave up. The answer choice must be C. Now question 21. There is a typo right here, right? This is exponential function. The exponential function k is divided by k of s equals 2 times 4 third raised to the s, right? So we need to get this one. Now we know that 4 thirds is going to be greater than 1, right? So it could be exponential growth function. So it could be something like this, right? Now, answer choice A. The function k is increasing. Yes, if you draw the tangent line, you see that the slope of the tangent line is positive, so the function is increasing, right? So we need to eliminate C and D. Now, the graph of k is concave up, right? So the answer must be A. Now, question number 22. The logarithmic function is divided by f of s equals negative 5 net log of s, right? We need to get this one. Alright, you know that the parent function of the logarithmic function is to be something like this, right? Now, since you have the negative 5 in front of the output, so there is a reflection over the x-axis, so it could be something like this, right? The function f is increasing or decreasing. You just draw the tangent line. You see that the tangent line is going down this way, which means the slope is negative, right? So the function is decreasing, right? So you need to eliminate A and B. Now, look at the rate of change. Because the function is concave up, right? So the rate of change is increasing, right? So this could be C right here. Now let's move on to question 23. The logarithmic function g is divided by g of s equals 3 times log base 5 of s, right? So the logarithmic function is going to be like this. Alright, so look at this one right here. The coefficient in front of log base 5 of s is positive, so there is no reflection, right? So it could be like this. Now, answer choice A. The function g is increasing, yes, right? Because you draw the tangent line, you see that the slope of the tangent line is positive. So the function g is increasing. So you need to eliminate C and D, right? Now look at the rate of change. The rate of change is increasing or decreasing. It's going to be decreasing because the function is concave down, right? So the answer must be B. Now let's move on to question 24. The function h is divided by h of s equals 4 times 2 to the s, right? So look at this one right here. This is exponential growth function, right? Because b equals 2 greater than 1, right? So it could be something like this, right? Look at the coefficient right here. It's going to be positive, right? So there is no reflection, right? The function h of s is increasing, right? Because you draw a tangent line, the slope is positive, right? So the function is increasing. We need to eliminate C and D, right? Now look at the rate of change. Because the function is concave up, the rate of change must be increasing, right? So the answer choice must be A. Now let's look at the question 25. The function f is divided by f of s equals 6 times 1/2 raised to the s, right? Now observe that b right here is 1/2 less than 1, right? So it's going to be exponential decay function, right? So it could be something like this. Now, since A is set positive, so there is no reflection, right? Now, we need to know if the function is increasing or decreasing. Draw the tangent line, right? So the slope is negative. The function is decreasing, right? So eliminate A and B. Since the function is concave up, the rate of change is increasing, right? So the answer choice C is correct. Now number 20, set the function k is defined by k of s equals negative 3 times 1/4 raised to the s, right? So we need to get this one. Alright, look at b right here. B equals 1/4, which is less than 1, right? So this is an exponential decay function, right? Now since a equals negative 3, so there is a reflection over the x-axis, right? So it could be something like this. Now look at the answer choice A. The function k is increasing. Now we need to draw the tangent line. And you see that the slope of the tangent line is positive. The function is increasing, right? So we need to eliminate C and D. We need to check for the rate of change, right? Since the function is concave down, the rate of change is decreasing, right? So the answer must be B. Now let's move on to question number 27. We need to sketch this graph, right? So we know that B is 3 greater than 1, right? So this is an exponential growth function, right? So it could be something like this. Now, since you have the negative coefficient in front of output, so there is a reflection over the x-axis, so it could be something like this, right? Now, I need to erase the previous one, right? Now, the function is decreasing, right? Because if you draw the tangent line, the slope is negative, so the function is decreasing, right? So we need to eliminate A and B, right? Now, we need to check for the rate of change. Because the function is concave down, the rate of change is decreasing, right? So the answer must be D. Now, since B equals 2 greater than 1, so this is exponential growth function, right? So it can be something like this. Now, since A equals negative 5, so there is a reflection over the x-axis, so it's going to be something like this. Now, in order to know if the function is increasing or decreasing, I'm going to draw the tangent line, right? And I know that the slope of the tangent line is negative, so the function is decreasing, right? So you need to eliminate A and B. Now, the rate of change is decreasing, right? Because the function is concave down, right? So the answer must be D. Now, question 29. We need to get this one. We know that the logarithmic function is going to be something like this, right? Now, look at the coefficient right here. It's going to be positive, so there is no reflection, right? Now look at the answer choice right here. The function g is decreasing. We need to draw the tangent line. And we know that the tangent line is going this way, the slope is positive, so the function is increasing, right? So you need to eliminate A and B. Now look at the rate of change. Because the function is concave down, the rate of change is decreasing, so the answer must be D. Now let's look at number 30. We need to sketch this one. Alright, so look at this one, you see that 2/3, which means b less than 1. This is exponential decay function, so it can be something like this, right? Now, in order to know if the function is increasing or decreasing, I'm going to draw the tangent line. So the tangent line is going down, the slope is negative, the function is decreasing, right? So I need to eliminate C and D. Now, the rate of change is increasing because the function is concave up, right? So the answer must be A. Now number 31. The function h is defined negative 6 times log base 2 of s. So I'm going to sketch this one. We know that the logarithmic function is going to be something like this, right? Since a equals negative 6, so there is a reflection over the x-axis. So it could be something like this, right? Alright, now in order to know if the function is increasing or decreasing, we need to draw the tangent line. And you see that the tangent line is going down, right? The slope is negative, the function is decreasing. So you need to eliminate C and D. Now look at the rate of change right here. The function is concave up, the rate of change is increasing. So the answer must be A. Now question 32, we need to sketch this one. You know that the logarithmic function is going to be something like this, right? Look at the coefficient A right here. This is positive, right? So there is no reflection, right? Now, in this question, they just ask you about the rate of change only, right? So we just draw the tangent line only, right? So the slope of the tangent line is positive, right? So the rate of change is positive, right? We need to eliminate C and D, right? Now, since the function is concave down, the rate of change is decreasing, right? So the answer must be B. Now question 33, we need to sketch this one, so it could be like this. B equals 4 greater than 1, right? So it could be exponential growth function. It could be something like this. Now look at the coefficient A right here. It could be negative 3, right? So there is a reflection over the x-axis, so it could be something like this, right? The rate of change of the function f is positive or negative, right? We just draw the tangent line. And we see that the tangent line is going down, the slope is negative, right? So the rate of change is negative. We need to eliminate A and B. Alright, since the function is concave down, the rate of change is decreasing. So the answer must be D. Now look at number 34. We need to sketch this one. Alright, you know that the logarithmic function is going to be something like this, right? Since A equals negative 2/3, so there is a reflection over the x-axis, right? So it could be something like this, right? Now I need to eliminate the previous one, right? Now the rate of change is positive or negative. We need to draw the tangent line. And you know that the tangent line is going this way, the slope is negative, right? We need to eliminate A and B, right? Now since the function is concave up, the rate of change is increasing, right? So the answer must be C. Now let's move on to the last two, 35 and 36. We need to sketch this one, right? Now b equals 3 over 5, which is less than 1. So this is an exponential decay function, right? Now since a equals 1, so there is no reflection, right? Now we need to check for the rate of change, is positive or negative, right? Draw the tangent line. The tangent line is going down, the slope is negative. The rate of change is negative, right? So we need to eliminate A and B, right? Now, since the function is concave up, the rate of change is increasing, right? So the answer must be C. Now, number 36, the function case is negative 1/5 times 9 to the s, right? So we need to sketch this one. Because b equals 9 greater than 1, so this is an exponential growth function, so it could be something like this, right? Now, since a equals negative 1/5, which means there is a reflection over the x-axis, so it could be something like this, right? Now, I need to eliminate the previous one. Alright, in order to find the rate of change, I need to sketch the tangent line, right? So the tangent line is going down. The slope is negative, right? So I need to eliminate A and B. Now, because the function is concave down, the rate of change is decreasing. So the answer must be D, right? And it's good time to stop. Thank you for watching. I hope you enjoyed the video. Remember that if you failing to prepare, you're preparing to fail.
We rise like tall buildings as the chemicals they take us high.